Hey everyone! In today's video we're going to be solving a formula through combustion analysis. So a little bit of stoichiometry, a little bit of empirical formula. In this question you burn 49 grams of a fuel containing carbon, hydrogen, and oxygen. So that's our little CXHYOZ because we don't know what it is. We have an excess of O2, and the clean burn produces 58.76 grams of water and 107.63 grams of carbon dioxide. And you have to determine the formula of the unknown fuel. How are we going to do this? Well, the trick is our carbon in the carbon dioxide is the same carbon as the carbon in our fuel. And the hydrogen in our water is going to be the same amount of hydrogen that's in our fuel. So if we can determine the mass of that carbon and that hydrogen, we can work backwards. So the step one that we're going to use in this case is we're going to determine the mass of hydrogen that's found in that water. We've been told that we have 58.76 grams of that water, and we're going to convert that and figure out of that 58.76 grams of water, how much is hydrogen. To do that, we're going to multiply by the total mass of hydrogen in the water. That's 2.02 grams. Each hydrogen's 1.01. Get that from your periodic table. And we're going to divide that by the total molar mass of water, 18.02, which we get by off the periodic table. That's going to equal 6.5869 grams. That's hydrogen. The rest of the mass of water is oxygen. We don't need that right now. We just need that hydrogen value. Once we have the hydrogen value, we're now going to slide over to our carbon dioxide, and we're going to determine the mass of carbon in the carbon dioxide using the exact same strategy. We've been given 107.63 grams of carbon dioxide. We're going to multiply that by the mass of carbon that makes up carbon dioxide. That's 12.01. That's the molar mass of carbon. We're going to divide that by the molar mass of the whole CO2. This is time saving. You could do percent composition and multiply it out. That'll take a lot longer. You can just do this in one step by multiplying by the molar mass of all the carbons in carbon dioxide, dividing by the molar mass of carbon dioxide. This gives us 29.3714 grams carbon. Now we know our carbon, now we know our hydrogen. That's what's in our fuel. We knew that we had 49 grams of fuel. Of those 49 grams of fuel, we have now shown that 6.5869 grams is hydrogen and 29.3714 grams is carbon. We don't know how much oxygen we have yet, but we're going to get that now. If we want to solve the mass of oxygen that's in our fuel, what we're going to do is we're going to take that 49 grams that we know that we started with, we're going to subtract the mass of hydrogen, 6.5869 grams, and we're going to subtract the mass of our carbon, 29.3714 grams, and that answer has to leave us with how much of our fuel was made up of oxygen. And we get that it's 13.0417 grams. Now we have our mass of hydrogen, we have our mass of carbon, and we have our mass of oxygen. The first half of this problem is done. First half? Oh no. Nah, don't worry. The second half is a lot easier. If you've gotten this far, you're going to knock this out no problem. Because in the second half, we're going to convert each of those values that were in grams into moles. Now this is where we get a little bit of stoichiometry going. Hopefully everyone out there knows how to convert grams into moles by using a molar mass. So we're just going to write out, and we have 6.5869 grams of hydrogen. To convert this into moles, we multiply by 1 mole divided by the mass of hydrogen on the periodic table. That's 1.01. I'm keeping 4 decimal places just because it makes things nice and tidy. If you're using your calculator, you can keep all of your decimal places. It doesn't matter. But when you're doing combustion analysis, please don't round early. It will cause you to get errors. So do not round early when you're doing combustion analysis, or you'll get a wonky answer later on. Better to keep more decimals. So here we are doing the same step with our carbon. We've taken our known mass of carbon that we have, and we're going to multiply that by 1 mole divided by the molar mass of carbon right off the periodic table, and that's going to equal 2.4456 moles of carbon. We're 2/3 done. Look at that. We've almost got this. One more stoichiometry calculation. We take that known mass of oxygen, 13.0417 grams of oxygen. To convert that into moles, we multiply it by 1 mole divided by the molar mass of oxygen from the periodic table. It's exactly 16. That's going to equal 0.8151 moles of oxygen. We are almost done. In order to finish this off, this is an empirical formula question. That means to finish this off, we divide all 3 of these answers by whichever answer was the smallest, in this case the oxygen. So we divide the hydrogen by 0.8151, we divide the carbon by 0.8151, and we divide the oxygen by itself. That'll be a fun calculation. If you've done this right, we should be getting some nice answers, and this is why we don't round early. When we divided the hydrogen, we get 8. And when we divide the carbon, we're going to divide that out, and we are going to get 3. And because the oxygen is the same number, 0.8151 divided by itself, it equals 1. And folks, this is the amount of each element we have in our formula. So we write C, we got a 3. We write our H, we've solved that that's an 8. And we write our O, and since that was a 1, we actually don't have to write any number at all. Hada! We have solved the formula of our unknown fuel using combustion analysis. It used a little bit of stoichiometry, it used a little bit of empirical formula, but in the end, we got it. If you have any questions at all, please leave them down below. I would be happy to answer. Otherwise, I hope this really helped you out and you can go off and solve some unknown fuels of your own. Thanks very much for watching.